Have you ever encountered a situation where your software test results didn't match your expectations? If you have, then you've experienced what we refer to as software testing errors. These are inconsistencies that creep up when we're trying to ascertain whether our software is behaving as it should or not. In the world of software testing, accuracy is king. The goal is to identify issues, bugs, or any form of irregularity that could affect the user's experience. A software test is like a detective, looking for clues and evidence to crack the case of what could go wrong. However, like any good detective story, there can be twists and turns. These twists and turns in software testing are errors, and they can significantly impact the overall performance of the software. Now let's consider a scenario where you've conducted a test and the results show that the software is bug-free. That's great news, right? But what if it turns out that there are indeed bugs and the test simply didn't catch them? Or what if the test flags an issue, but in reality there's no issue at all? These are examples of the two most common types of software testing errors: false positives and false negatives. A false positive is like crying wolf when there's no wolf. The test wrongly indicates a problem where none exists. On the other hand, a false negative is the silent wolf. The test fails to detect an issue that is actually present. Both errors can lead to significant problems. False positives can waste time and resources chasing non-existent bugs, while false negatives can result in releasing a bug-infested software to the users. Understanding these errors, their impacts, and how to mitigate them is crucial in the realm of software testing. As we delve deeper into this topic, we'll uncover the nuances of these errors and learn how to effectively handle them. So what exactly are false positives and negatives? Let's dive in. Imagine you're using a bug detection tool and it flags a non-existent bug. Frustrating, right? That's a false positive. So what exactly are false positives? In the simplest terms, a false positive is when something is identified as a problem, but in reality, it isn't. It's like your fire alarm going off when there's no fire at all. Imagine you're cooking up a storm in the kitchen and the steam from your boiling pasta water sets off the fire alarm. There's no fire, no danger, but the alarm thinks there is. That's a false positive. In the realm of software testing, a false positive is when your bug detection tool flags an error or bug that doesn't actually exist. It's like the software's fire alarm going off because it mistook some harmless code for a dangerous bug. Now, why are these false positives a problem? Well, they can be quite a nuisance. They cost time, energy, and resources. Think about it. Each time the alarm goes off, you drop everything and rush to check it out, only to find there's no fire. Similarly, each time a false positive appears, developers have to stop their work, investigate the flagged code, and determine that it's not a bug after all. This process can be time-consuming and, frankly, quite frustrating. Moreover, false positives can lead to a boy who cried wolf scenario. If the alarm goes off too many times without a real fire, you might start ignoring it. In software testing, too many false positives might lead testers to disregard genuine bugs. That's a risk no one wants to take. So, false positives can indeed be a drain on resources and can potentially compromise the efficiency of your software testing process. They're like those pesky false alarms that cause unnecessary panic and disruption. False positives can indeed be misleading, but what about false negatives? They have their own set of challenges. Now picture this. A bug is wreaking havoc in your code, but your testing tool is silent. That's a false negative. Imagine you've installed a burglar alarm in your house to safeguard your precious assets. One night a burglar breaks in, but your alarm stays silent. The burglar is analogous to a bug in your software, and the silent alarm represents a false negative in software testing. A false negative occurs when a testing tool fails to detect an existing bug or defect in the system. Just like the silent alarm allows the burglar to loot your house undetected, a false negative lets a bug slip through the testing process, hiding in your software, waiting to cause potential problems down the line. This could lead to system failures, data corruption, or worse, it might even expose your system to security vulnerabilities. The impact of false negatives is often severe and far-reaching. They can result in unexpected system crashes or complete system failure, bringing your operations to a standstill. Imagine launching a significant software update, only to find your system buckling under a bug that slipped through due to a false negative. Not a pretty picture, is it? False negatives are like ticking time bombs, quietly threatening to explode at the most inopportune moments. They can lead to loss of customer trust, damage to your brand reputation, and in severe cases, they can even lead to financial losses. But why do false negatives occur? They can be a result of incomplete or inefficient testing processes, or perhaps the testing tool used was not sophisticated enough to detect the bug. Sometimes it could be due to human error, where the tester might have overlooked the bug. In essence, false negatives are silent killers in the realm of software testing. They give us a false sense of security, making us believe that our software is bug-free and ready for deployment, while in reality, it might be teeming with hidden bugs. False negatives can be dangerous as they give a false sense of security. But how do they compare to false positives? False positives and negatives might seem similar, but they're quite different. Let's dive into their key differences and how they impact the world of software testing. Firstly, the nature of these errors is fundamentally different. A false positive is a test result that incorrectly indicates the presence of a bug, an error, or a defect that doesn't actually exist. It's like a smoke alarm going off when there's no fire. On the other hand, a false negative is a test result that incorrectly indicates the absence of a bug, an error, or a defect that is actually there. It's like a smoke alarm staying silent while a fire is raging. These differences translate into different impacts on the testing process. False positives can lead to wasted resources. Imagine all the time spent investigating a bug that doesn't exist, or the efforts put into fixing a problem that was never there. It's a drain on manpower, time, and money. False negatives, however, are even more dangerous. They give a false sense of security, suggesting that everything is fine when it actually isn't. This can lead to serious issues slipping through the net, which might cause significant damage when the software is deployed. It's like a ticking time bomb waiting to explode. Then there's the aspect of risk. False positives can lead to frustration and exhaustion among the software testing team as they chase after ghosts. They can also erode trust in the testing process if they occur frequently. False negatives, on the other hand, pose a much bigger risk. They can lead to undetected issues that might cause software to malfunction, leading to user dissatisfaction, reputational damage, and potential financial losses. So, what we're looking at here are two sides of the same coin, both problematic but in different ways. And that's what makes software testing such a challenging field. Understanding these differences can help you better manage your testing process. Because at the end of the day, a good software tester isn't just about finding bugs. It's about understanding what those bugs mean and what they don't. Now that we've understood false positives and negatives, how do we deal with them? Let's dive right in. First off, regular system checks are crucial. Why, you ask? Well, because they help you maintain an updated understanding of your software's performance. Regular checks allow you to catch inconsistencies early, enabling swift rectification. Think of it like your regular health checkup. You wouldn't want to miss a potential issue, would you? The same applies here. Now, onto the second strategy, using reliable testing tools. Imagine you're a detective and your testing tool is your magnifying glass. You'd want the best magnifying glass to find all the clues, right? Similarly, reliable testing tools help you detect issues accurately, reducing the chances of false positives and negatives. They provide precise, consistent results, ensuring your software testing is as effective as possible. Lastly, don't underestimate the power of a thorough manual review. As advanced as our tools and technology may be, they're not infallible. A manual review serves as a second line of defense against false positives and negatives. It's like having a second pair of eyes, ensuring nothing slips through the cracks. This way, you can validate the results from your automated tests and catch any anomalies. However, remember that mitigation doesn't mean elimination. False positives and negatives can still occur, and that's okay. The goal here isn't to eliminate them entirely, that's nearly impossible. Rather, it's to minimize their occurrence and impact. Think of it as damage control. In conclusion, mitigating false positives and negatives involves a three-pronged approach: regular system checks, using reliable testing tools, and thorough manual reviews. Each strategy complements the others, creating a well-rounded approach to software testing. Remember, effective software testing is all about accuracy. Don't let false positives and negatives derail your testing process. Keep these strategies in mind and you'll be well on your way to more accurate and efficient testing.